Today we are going to use this quadratic formula to solve, but we're also going to end up using another method. So there are 8 problems today, and you're going to end up using factoring would probably be the best way to do it, and then also the quadratic formula. And you'll end up seeing you get the same results. So this way you can see which method you like better. Well, for either method, we're going to end up having to set the equations equal to 0. So we need to move this term over. And the way you move a term is you just do the opposite operation. And then put it in descending order. So it's now x squared plus x minus 12 all equals 0. For the quadratic formula, we're going to end up figuring out our a, b, and c terms. So I wrote the quadratic formula here. And again, the a term is the number out in front of x squared. B is the number out in front of x, and c is the constant, as long as this is set equal to 0. So here we're going to go ahead and use the a value is 1, the b value is also 1, and the c value is negative 12. You got to look at the sign out in front as well. So we just substitute the numbers in there. So we have the opposite of b, so negative 1 plus or minus the square root of 1 squared minus 4 times a, which is 1, c is negative 12. And this is all over, so that fraction bar goes underneath every single number there, all over 2 times 1, 2a. So we go ahead and do some more work there. We can combine some terms and multiply some numbers. So underneath the radical sign, we still have this 1, because 1 squared is 1. And then watch the signs here. You see how the negative times the negative make a positive? And when we multiply the 4, the 1, and the 12, we end up with a positive 48. And this is all over 2. Well, we can go ahead and collect those two terms underneath the radical sign. So now we have negative 1 plus or minus the square root of 49 all over 2. Well, we can go ahead and take the square root of 49, and that makes 7. So we have negative 1 plus or minus 7 all over 2. And then we can set up our two problems. We've got negative 1 plus 7. Oops, let me go ahead and fix that real quick. That negative 1 plus 7 all over 2. And we also have negative 1 minus 7 all over 2. So when we do the work up on top, we've got a 6 over 2, which makes 3 when we reduce that fraction. And then over here we have a negative 8. Negative 8 over 2. Again, this was a 7 here. Negative 1 minus 7 makes negative 8 over 2, and that leaves us with negative 4. So those are our two x-intercepts, two solutions. And so again, we can get the same answer using other methods. Completing the square, factoring, they all give us the same exact answers. Now let's go ahead and solve by factoring in this one. So if I factor, I've got numbers that multiply to make 12, but subtract to make 1. So it'd be x plus 4 and an x minus 3. And I set that equal to 0. When I go ahead and solve, I'm setting the two factors equal to 0, coming up with the two solutions. So here I end up having to add or subtract the 4 from all sides, and that's how I'm getting the negative 4, the same answer I have here. Here I end up having to add 3, and that's how I'm getting the other answers. So you can see how factoring is really fast. It's the fastest method. And I would always recommend trying to factor first because you can come up with the answer pretty quick. However, not all quadratics are factorable. And so that's why we need to have another method like completing the square or quadratic formula. Well, let's take a look at another one here. And so here again, we're moving terms over. So I need to add this 7x to all sides. So the 7x is going to go right in between these two terms. So I've now got x squared plus 7x plus 12. And so from that point, I could go ahead and figure out my a, b, and c terms. So my a term is equal to the number out in front of x squared, 1. b is equal to 7, the number out in front of x. And c is the constant, 12. And so I'm using those numbers and just putting them in that quadratic formula. So it goes the opposite of b, so negative 7, plus or minus the square root of b squared. So 7 squared minus 4 times a, which is 1, c is 12. This is all over 2 times by 1. Well, we do some work there underneath that radical sign, and this is what we've got. We've got negative 7 plus or minus the square root, and then we've got 49 minus 48. This time it's a minus because there's only one negative. Whenever a and c are the same sign, that means that you're going to end up having to subtract because they end up having just an odd number of negatives. So negative times a positive makes the negative sign. And this is all over 2. So we do some more work there. Underneath that radical sign, combine those two terms. We've got a negative 7 plus or minus the square root of 1 left over, all over 2. Well, we take the square root of 1, you end up with 1. So we've now got negative 7 plus or minus 1 over 2. And we can now set up our two problems. Negative 7 plus 1 over 2. Let's fix that real quick. Put a comma in there, didn't mean to. So negative 7 plus the 1 over 2. And we also have the negative 7 minus the 1 all over 2. So we go ahead and do that work. Negative 6 over 2 makes negative 3. That's one of the solutions. Over on this side, we get negative 8 because they're the same sign. Over 2 makes the negative 4. So there it is. Negative 3, negative 4, the two x-intercepts. Again, I get the same answer if I factor this. So I'll factor this trinomial that's right over here. And I end up with a x plus 4 and an x plus 3. And when we go ahead and use that zero product property, I'm doing x plus 4 equals 0. And I do the x plus 3 equals 0. And so when I go ahead and solve this, I'm just doing an opposite operation, moving that 4 over to the other side. Here I'm moving the 3 back to the other side. And so I end up with my two answers of negative 4 and a negative 3. The two x-intercepts. So those are my two solutions. Well, taking a look at the next one. A little bit different. This time we've got a number out in front of x squared that's different, and also everything's set equal to 0. So it's really set up for us to use our methods here of either quadratic formula or factoring. So a is 2, b is 7, and c is 6. So we're just substituting those numbers in there. The opposite of b, so negative 7 plus or minus the square root of b squared. So 7 squared minus 4 times a, which is 2. And c is 6, and this is all over 2 times by 2. Doing some work underneath that radical sign. Now I've got a negative 7 plus or minus the square root, and I've got 49 now. And then here I've got a minus sign because there's only one negative. An odd number of negatives makes a negative. So negative 4 times 2 makes negative 8 times 6 makes, oh, another negative 48. Add that number each time now. Okay, so over 4. First time I had a positive, but same number, just opposite signs. And we continue to solve. Negative 7 plus or minus the square root of 1 over 4. When I take that square root of 1, I've done that before. That just makes 1. And this is all over 4. So now we can set up our two problems. Negative 7 plus 1 over 4. And we also have negative 7 minus 1 all over 4. So here we end up with negative 6/4, which reduces down to negative 3 over 2. Over here we have negative 8/4, which reduces down to negative 2. So those are our two x-intercepts. And we get the same answer if we factor. So it's set up for factoring. It's set equal to 0 already. 2x and x make 2x squared. Numbers that multiply to make 6 are like 3 and 2. Just got to figure out the order so that the outside and inside terms add to make 7. Could also try 6 and 1 as well if those don't work, if the 3 and the 2 don't work. But if I try let's try a 2 here and a 3 here. See, those outside terms make 4x, inside make 3x. Those do add to make 7. Put the plus signs in there, and then set those factors equal to 0. So here's what we've got. We got a 2x plus 3 equals 0, and we also have a x plus 2 equals 0. So when we go ahead and solve this first one, we have to do an opposite operation here. Subtract the 3. Here we're just subtracting 2. We've got one of the answers is x equals negative 2, but over here we have to do some division. So we got 2x equals negative 3. Divide by 2. We get our answer. So negative 3 halves is 1. Negative 2 is the other. Same answer we get using the quadratic formula. So factoring takes up less space. It's a little faster. But quadratic formula works for all problems where factoring doesn't. Well, taking a look at the next one, we've got to move this 4x over first. Always isolate all the terms onto one side of the equal sign. So now I got x squared minus a 4x plus 3 equals 0. The reason why that's important, especially for the quadratic formula, is you got to get the right sign in front of the term. So a is 1, b is now negative 4, and c is 3. So you're substituting those numbers into your formula. It's the opposite of b, so negative 4 becomes a positive 4. So opposite of negative is positive 4, plus or minus the square root of negative 4 squared, minus 4 times a, which is 1, c, which is 3, and this is all over 2 times 1, 2a. So we do a little more work. We got 4 plus or minus the square root, and then now we've got 16, and this is a minus. Actually, it's going to be a plus. Let's see here. Let me check the signs here. Nope, it's a positive 1 and a positive 3. Whenever the a in the c terms are the same sign, then you'll end up subtracting because you'll have an odd number of negatives when you multiply the 4ac, because it's always minus 4 and then a and c. So one negative makes a negative, so it's going to be minus 12 all over 2. When we do that work, we got 4 plus or minus the square root of 4 all over 2. And so we can go ahead and take that square root, which is 2, and this is all over 2, and set up our two problems now. So again, we've got the 4 plus the 2 all over 2, and we also have the 4 minus the 2 all over 2. So it makes 6 halves, which makes 3. Over here we got 2 halves, which makes 1. So those are the two x-intercepts. Well, we could still solve by factoring. That's what the directions say, is to solve using two methods. So factoring is the other method I would use. Numbers that multiply to make positive 3, but add to make a negative 4. Means the signs have to be the same, both negative in this case. And we go ahead and use opposite operations to solve them. And we just have to do that adding of 3 to both sides. Over here we have to add 1. And we get our answers, the same answers we got using the quadratic formula, 3 and 1. So that's it. That's what you're going to see on tonight's homework. Good luck.